Okay, Nishita, let me see if I can explain this on a screencast. We're trying to find the area underneath this curve, um, so this region right in there. And the idea of a Monte Carlo approach is that we're just randomly throwing in points into a known area and seeing how many fall within our unknown area. So let's imagine putting a box around this curve. So now we've created this box around the curve that goes, this base is going from -2 to 2, then we're going from, y value from 0 up to 4. So we've got a length of 4 here, a length of 4 there. So we've made just a nice little box. And we know the area of that. We know the area of that is going to be, a 4 by 4, 16. So what Mathematica can do is it can randomly generate numbers. So this command random real is going to be what you're doing. So if we were to run that, what that does is just generates a random number between 0 and 20. So if I ran it again and again, I'm going to get a bunch of different numbers. But what I want to do is I want to say, let's define the x value to be a random number, and I want the x values to range from -2 to 2, because I want the x to fall in that x range. And my y values are ranging from 0 to 4, so my y values are going to go similarly from 0 to 4. And what I want to do is I want to print x comma y. I don't even know if that's going to work. Let's try this. Print x, print y. So here's my x value, here's my y value. And so if we think about, this as being a coordinate 1, comma 1.3, that's going to be somewhere in here. So that would fall inside my parabola. Well, if I ran it again, then I get the point 0.5, 3.47, so like 0.5, 3.47, so somewhere in there. What I want to do is I want to check, is that point underneath the curve? So let's define the function. Let's say f of x is -x squared plus 4. And what I want to do is I want to see, is my x value that I created, the xy point inside the curve. So I can say if f of x, and now just to keep the variables from being too weird, I'm going to call this a and this b. So where a is my x value, b is my y value, so I'm going to say if f of a it's clear to say if b is less than f of a, print inside. So if I run this a couple times, most of the time it's going to say inside. But in this case it didn't say inside, which meant the point was outside of the curve. If I run it again, inside the curve. Sorry. So what you see is that sometimes the point falls inside the curve, sometimes the point does not fall inside the curve. What we want to do is we just want to run this whole thing a bunch of times and count what percentage of the points fall inside the curve. So maybe we could say, let's say we start with a counter equals 0, and while I is less than 10,000, we're going to generate an A number, generate a B number. And if B is less than f of A, instead of just printing inside, now what I want to do is I want to say, let's add 1 to my counter. And do I++ to increase that. And now what we should do is, what we want to do is we want to say print the area of the square, which is 4 times 4, times the proportion of the points that were inside the curve. So that's counter over 10,000. And this should give us an approximation for the area of the curve. And to get it a little bit nicer, so we have an area of about 10.7 it's approximating, and that makes sense because we would expect the area of the box is 16, so there's a little bit less. So that number is within a close enough to suggest some accuracy. It is in fact very close to being right. So this is the code that will do that. And just a comment here, what we're doing is defining the function, developing counters, doing an algorithmic process, defining an x value, defining a y value, and then in this case we're checking to see if the point is inside the graph. And now we're printing out. What are we printing? Printing the area of the rectangle, which in this case is a square, multiplied by the fraction of the points inside the graph.